first part, we should continue our discussion about HTTP, and we have to focus on two important things. One of them is the idea of REST, representational state transfer, and what we're going to use it for. Because our backend, the backend of the type of applications we're going to write, are written on this, let's call it methodology. And let's see what the previous approaches were basically and what advantages we gained through this. This is a classical problem, which is remotely accessing objects via the web. Right? And it's had multiple solutions, from XML RPC to SOAP, and now REST. And REST is the current state-of-the-art approach. If we compare REST to something like SOAP, in SOAP, we access the object by getting a description of the object via a special XML-derived language, which is called WSDL. So we had to download something separate, and then we'd call the methods of that particular object via XML. But the vocabulary of the object couldn't be discovered intuitively, right? So I had to have a description. It could have any vocabulary. By vocabulary meaning, I mean what operations I could invoke on that particular object. Right? We could think about this like substantives, which are the objects themselves, and verbs, which are what I can ask them to do. Now, if I look at REST actually tried to shift this to something which uses only HTTP mechanisms, and it has the advantage of having a limited vocabulary, which means that the vocabulary is going to be standard, right? So I can, if I look at some RESTful endpoints, so combinations of method and address, I'm going to be able to understand what they're supposed to do. And I recommend that you look over the PayPal RESTful API, because PayPal itself handles a relatively difficult thing, right? So the phenomena that I'm reflecting in software is relatively complicated. It's payments in all its aspects, which means which is something I can't simplify, right? It's just what it is, what I'm supposed to program. But it's really easy to understand if you understand what the entities mean, right? If you know what a billing agreement would mean, it's really easy to understand the operations on them. So let's take an example. So let's imagine a hypothetical object which is going to be a widget, right? Doesn't matter what that is. And this is part of the point. So what I'm going to do is this. I'm going to see how my operations would look reflected in this. Right? So if I say something like method get address widgets, what I'd expect from this is that it's going to give me a list of all widgets. If I want a particular widget, I do something like this. And this is going to be a parameter. Right? So that's a particular widget. Now, and this will apply to any entity I'm accessing for the typical methods. There are some limitations to this, and we'll get into that. But let's say I want to add a widget. I can't actually add an existing widget. So the only way this would make sense is post a new widget to widget. Right? Now, if I'd want to edit a widget, I couldn't possibly edit a non-existing widget, which is going to say that it's going to be put widget ID. And if I want to delete a widget, I'm going to do something like that. And notice that the first thing on the line is actually an HTTP method. I'm not extending HTTP for anything. So this is how my, let's say, the interface of my widget would look like. Now, something to note here. First of all, some of these methods have nothing in the request body. Some of them have something in the request body. But this is also intuitive. If I request the server to give me a widget, I don't send it anything. And I'm waiting for something from the server. If I delete a widget, I just want the information that I either deleted it or couldn't. If I add a widget, I expect that a version, the first version of this widget is in the request body. And the way we're going to actually send the object in these instances where I have to send something is going to be through JSON. And JSON is a way of serializing objects over HTTP, which is very similar to the way objects are actually represented in JavaScript. JSON means JavaScript object notation. It's not the same as in JavaScript, but it's extremely similar. So for example, if I add a widget and my widget had a name and a type, it would be something like this. Right, so it's going to be a series of key value pairs. Now, the advantage to this is that at a fundamentally intuitive level, I can think of objects as a series of key value pairs, right? Think about it this way. If I'm talking about the properties of an object, I have the name of the property and the particular value for that particular object. If I have the behavior of an object, so a method, I might have something, it depends on my language, but I'd have the name of the method and either the address of the code, if my language is a system level, a low level one, or I'd have the method itself if the language actually covers, supports functions as values. And you've seen this, when you've learned Java, you've actually seen this, although in a rather more limited capacity, because you have lambdas, and lambdas are what? Are functions as values, right? So they're functions which you can store in variables. JavaScript actually has a mechanism which is a bit more powerful. It's thought as a fundamentally functional language. So this works precisely like that. Now, the second thing we must think about is that there are some situations where this interface might need something which extends it, right? So let's say I have some active widgets and some inactive widgets. If I have something simple like this, like a filter, I might support a parameter like this. Active, yes. Right. However, if I have this is basically a filtering or a search expression. If I have search expressions which are more complicated, what I'd end up doing is defining my own search language. And instead of doing that, I might use a pre-existing search language. For example, there's GraphQL, and there are a lot of pre-implemented languages which I can use over my JavaScript libraries. Now, the third thing I have to discuss is what happens if I have some relationship between my objects, my types. For example, if a widget has components, I might opt to pass all the management of that relation to the implementer, right? And just treat components as something separate and let the programmer handle the rest. But in some situations, I might want to reflect the relationship between widgets and components. And those endpoints, let's start from the ones we already have. Those endpoints would look like this, and again, it's intuitive. If I'd want the components of a particular widget, I'd have something like this. So widget ID, components. If I'd want a particular component of a particular widget, right? Again, it's intuitive. It's like this. So what I get is an almost self-documenting interface, right? So component ID. If I'd want to add a component, the URL is going to look like this, right? It's a post to the components of a particular widget. If I'd want to edit a component, right? I have something like this. Edit a component of a particular widget. And see, this reflects the actual structure of my object. If I want to delete one, again, it will look like this. Okay, so this is the principle, let's say, behind REST. We're obviously going to get to this again when we're going to write our own RESTful services with Node and Express. Do you have any questions until now? Well, the second thing we didn't get to discuss last time is that while HTTP has had a certain version of the standard for a long, long time, recently we have a new version, which is HTTP 2. Now, the adoption rate of this version is going to be a lot more accelerated than any new version of a pre-existing standard, because HTTP itself has a series of mechanisms which allow me to function with both the standards, to function in a situation where the standard is partially implemented. If you think about what we discussed last time, if the client requests something of the server that the server doesn't understand, what's going to happen is that the server is just going to ignore it. And on any HTTP connection, the client might request to elevate the connection to HTTP 2. And if the server supports this, this is going to work. If not, it's not going to work, but we're still going to have communication without any particular problem. Now, what does HTTP 2 bring to the table? So first of all, it's a binary protocol, so it's a bit more efficient. Second of all, if I look at something, let's do a request to the site of the university, which is not HTTP 2 enabled. Okay, so let's go to network. Right. I noticed a series of things. First of all, in my view, I requested one resource, but I've actually requested a lot of resources. There's 76 requests here. Second of all, after I've received the index, I had to parse it and understand what's in it, and then request the rest of the things, right? Because if I look at the index, let's look at the index, I'm going to see that I have these link tabs, right, which include other resources. So I had to first read them, and then I could request the other resources. Thirdly, we talked about how HTTP supports compression, but it supports compression for message bodies. But if I look at this request, look at the request, right. If I look at the response headers, for example, and the request headers, I'm going to see I have quite a lot of headers. Right? There's a lot of headers. And these are not compressible. While in HTTP 2, I have compression for these two. Moreover, the compression is on what's called a frame level, which means I can receive a piece of the headers and then a piece of the content, and so forth. For example, if I request this index, the server will also know that I need those CSSs. I'm necessarily going to need them. And it's going to have server push. So it's going to try to push the resources to me because it knows I'm going to need them. And this is done via HTTP headers. There's no new mechanism. If I look at something which does support HTTP 2, let's go to Google. As an aside, HTTP 2 is actually a protocol which existed internally at Google, which is called SPDY. And it's an evolution of that protocol. So that's why we're expecting that Google is going to support it. Let's see if we can see this more clearly. Yeah, so see, for example, methods and everything, they're marked as if there'd be special headers. And they're also liable for compression. Right? I get a lot more efficiency. Read an article somewhere, some people actually measured what the efficiency is. Can't tell you off the top of my head, but I could add the link to the article in case you're interested. So I have a series of advantages. Obviously, not all of this is implemented. But for example, if I'd want server push for this optimization thing, where I'd push dependent resources, I already have a framework, something which can be added on top of Express to support it. Right? So I can do it in Node.js at this particular time. Okay, so this is, I think, what we had to talk about. Let me just stop this.